Okay, another useful set of equations, the equations of constant acceleration. Underlining that because these can only be used when the acceleration is constant. For example, falling under gravity, acceleration will be negative 10 meters per second squared. Negative 9.8, negative 10 is fine for our purposes. So the XUVAT, the xuvat equations, X stands for distance, U is the initial velocity, and V is the final velocity. It's important that you keep those straight. A is the acceleration, and T is time. And of course, distance will always be in meters. Velocity is always in meters per second. Acceleration, as we saw before, meters per second squared. So the 5 equations, you'll notice each of these equations is a combination of 4 quantities. So each of these is missing 1. So you'll notice this first one has no A. A is missing from this one. This one has no X. This next one, there's no V in this one. This one has no U. And this last one is missing T. So generally with these questions you need 3 things that you know and 1 that you don't, that you're trying to find. So steps to step 1 is always draw a diagram. Drawing a diagram is a great way to just figure out and keep straight in your head what's going on. So I'm going to insist that you draw a diagram for all these questions. It's really important that you then set positive and negative directions for everything so that you know which way is up, which way is down, which way is positive, and which way is negative. Because most of these quantities are vectors, it's very important that you get your positives and negatives straight. Number 3, list what you know. List down all the quantities that you know that you're given in the question. You might be given, it might be a situation where something's falling under gravity over a certain amount of time. It might be starting from rest, in which case U would be 0, and you're asked to find the final velocity, what is V. So step 4, identify what you need to find. So I want to see you making little lists like this as well as your diagram. Once you've got that, you can choose an equation. Once you see your 3 things that you know, 1, 2, 3 quantities that you know and the 1 that you don't, you're in a position to choose an equation. Step 6 is of course to solve for your unknown quantity. Okay, let's look at an example. Anvil launching. Some of you might have seen this on Hamish and Andy. It's an American thing where people stack a bunch of gunpowder underneath a big heavy anvil, launch it up into the air. I'll let you look it up on YouTube. It's worth watching. Anyway, so in this example, an anvil is launched up into the air and it's in the air for 7 seconds. So 3.5 seconds up, 3.5 seconds down. How high did it go? Our challenge is to use xuvat equations to work out how high that anvil went in the air. So first step, sketching a diagram. Here's the anvil at the start, and then it flies up into the air and turns around, comes back down again. We know it's 3.5 seconds going up and 3.5 seconds going down. It's going to be useful for us to only consider the first half of this motion, this bit here. If we consider the whole journey, then the displacement will be 0, and that wouldn't be very helpful for us. So what we're going to do is just consider the first half of the trip. Going up from some initial starting velocity will be very high as it's launched, but then when it gets to the top, it'll have a final velocity of 0, and that should be more useful to us. So next step, let's make a list. Wait, first we need to define our directions. We'll define up as positive. So that direction is positive. So now when we make our list, acceleration due to gravity will be negative 10. And we should expect a positive answer for displacement here. So acceleration is negative 10. The time for that first half of the journey is 3.5 seconds. And the final velocity for that section will be 0. because it comes to rest when it's up here at the top of its flight. And the thing we're asked to find is x. So x is our unknown. So looking at those quantities, it's clear that we need to choose a equation. So we have no u. And so the equation that we're going to go with here is x equals vt minus 1/2 a t squared. So when we put our variables in, we see conveniently that this first term goes to 0. V is 0, and so this whole term goes to 0. 0 minus 1/2 times negative 10 times 3.5 squared. And so solving that, we see that negative 1/2 times negative 10 would be positive 5. 5 times 3.5 squared gives us 61.25 meters. So even with such limited initial information, we were able to use that equation of constant acceleration to figure out how high the Anvil went. It flew 61.25 meters in the air.